Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the enthalpy of moist air and HD chart. Let's first talk about the enthalpy of moist air. The temperature of air in air conditioning applications ranges from about -10 to about 50 degrees centigrade. In this range, dry air can be treated as an ideal gas with a constant Cp value of 1.005 kJ over kilogram Kelvin with negligible error. Taking 0 degrees centigrade as a reference temperature, the enthalpy and enthalpy change of dry air can be determined from, where T is the air temperature in degrees centigrade and delta T is a change in temperature. In air conditioning process, we concern with the changes in enthalpy delta H, which is independent of the reference point selected. Since water vapor is an ideal gas, the enthalpy of water vapor is a function of temperature only, that is, H equals HT. This can also be observed from the TS diagram of water given in the figure, where the constant enthalpy lines coincide with constant temperature lines and temperatures below 50 degrees centigrade. Therefore, the enthalpy of water vapor in air can be taken to be equal to the enthalpy of saturated vapor at the same temperature. The enthalpy of water vapor at 0 degrees centigrade is 2500.9 kJ over kilogram. The average Cp value of water vapor in the temperature range -10 to 50 degrees centigrade can be taken to be 1.82 kJ per kilogram degree centigrade. Then the enthalpy of water vapor can be determined approximately from this relation, where T is the vapor temperature in degrees centigrade and in the temperature range -10 to 50 degrees centigrade. This relation is with negligible error. In most practical applications, the amount of dry air in the air-water vapor mixture remains constant, but the amount of water vapor changes. Therefore, the enthalpy of atmospheric air is expressed per unit mass of dry air. Also, the enthalpy for air or saturated vapor can be found from the tables. In principle, the calculation of humid air is possible with the above formula. Practically, to facilitate the calculation of the humid air process, the thermal properties of the humid air can be plotted as a graph for a specified pressure. Now, let's talk about the enthalpy of moist air. The state of the atmospheric air at a specified pressure is completely specified by two independent intensive properties. The rest of the properties can be calculated easily from the previous relations. The sizing of a typical air conditioning system involves numerous such calculations, which may eventually get on the nerves of even the most patient engineers. Therefore, there is clear motivation to computerize calculations or to do these calculations once and to present the data in the form of easily readable charts. Such charts are called psychrometric charts, and they are used extensively in air conditioning applications. Psychrometric charts are used extensively in air conditioning applications. They serve as a valuable aid in visualizing the air conditioning process, such as heating, cooling, and humidification. Note, the HD chart of humid air is drawn under a certain total pressure. That is, one chart is suitable for only one total pressure. Finally, let's talk about the constant lines in psychrometric chart. Obviously, there are several constant lines. Firstly, the fixed moisture constant line. Secondly, the fixed enthalpy lines. Thirdly, the fixed dry bulb temperature lines. Fourthly, the fixed relative humidity lines. Fifthly, the fixed volume lines. Sixthly, the water vapor pressure PV and specific humidity D conversion line. Since the usual enthalpy and humidity charts are drawn for the specified humid air pressure, it is only applicable to the specified pressure. So, different enthalpy and humidity charts for different humidity air pressures may be drawn. Okay, that's all for this task. Thank you very much and see you next time.